Hello students, so continuing our lectures on mathematical physics, we will discuss some statistical distributions here. Now, the first statistical distribution is that we will discuss is the binomial distribution. Now, the probability of obtaining x any value it increases, x success is in n independent trials. So it is if x we are getting a success, and this is the number of trials. Now, if the probability of success is p, probability of success is p, and the q is the probability of failure in a single trial, then the binomial distribution is given as b x, and it is equal to n factorial, n is the number of trials, into divided by x factorial, the event that is success, n minus x factorial into p to the power x into q to the power n minus x, and it is also written as cnx into px q n minus x. So this quantity n factorial divided by x factorial into n minus x factorial, this is actually the relationship of combination. So this is also called a combination. It's combination multiplied by the probability of obtaining success, that is p to the power the event into q divided by number of events which are failure, so n minus x. So this is the binomial distribution. Now this binomial distribution is normalized. So bx is normalized. So we can write summation x is equal to 0 to the power n into bx is equal to 1. So it is a discrete distribution. So that is why an integration, instead of integration, a summation has been used, and the mean value x is equal to n number of events into probability of getting success, whereas the standard deviation st given as sigma is equal to root over number of events into probability of success into probability of failure. So this was all about binomial distribution. Another type of distribution is called Poisson distribution. So the probability that x events, if x is the events of will occur in per unit time, where the mean rate of occurrence is m. So if rate of occurrence is equal to m, the probability that x will occur per unit time is given by this Poisson's distribution, which is called px and px is equal to e to the power minus m. The rate of occurrence is m to the power x, the number of events per unit time, divided by x factorial, and where x can take up value 0, 1, 2, 3, etc. So like Barnable distribution, polynomial Poisson distribution is also normalized. So that makes x is equal to 0 to infinity, px is equal to 1. That means if you take all the distribution, it comes equal to 1. It is also a discrete distribution, like in the case of Van Allen distribution. Now when n number of events into probability of success is held fixed, then binomial distribution, it tends to Poisson distribution as n is increased to infinity. So in the case of Poisson's distribution, the expectation value of the event is equal to the success rate, is equal to the rate of occurrence, and the standard deviation sigma is simply root of m, and the properties of the polynomial distribution, the Poisson distributions are pm minus 1 is equal to pm, and p x minus 1 is equal to x by m pm, and px plus 1 is equal to m divided by m plus 1 into px. So the next distribution is called the normal or Gaussian distribution. So here, when the probability of success is held fixed, the binomial distribution tends to normal distribution. Binomial distribution, it tends to normal distribution as n is increased to infinity. And the interesting thing about Poisson is, unlike Poisson and binomial distribution, it is a continuous distribution. Continuous. So instead of a summation sign, we will use a integration sign here. So this expression, the distribution is given as fx dx is equal to 1 by root 2 pi sigma e to the power minus x minus m whole square divided by 2 sigma square into dx, where m is the mean and standard deviation is the sigma. Apart from these distributions, we have something called an interval distribution. If the data contains n time intervals, and the number of intervals is n between t1 and t2. So there are n time intervals, the number of intervals is n, then we can write n is equal to n, capital N, e to the power minus a t1 minus e to the power minus a t2, where a is the average number of intervals per unit time. Average number of intervals per unit time. Short intervals are more favored than long intervals. And short intervals are more favored than long intervals. There are two limiting cases. First one is T2 is equal to infinity, and n, capital N, is equal to n0 e to the power minus lambda t. So this is nothing but the law of radioactivity. This gives the number of surviving atoms at time. So it gives the number of surviving atoms per unit time t, and the second one is t1 is equal to 0, then n is equal to n0 1 minus e to the power minus lambda t. For radioactive decays, this number gives a number of decays at interval 0 and time. So it gives the number of decays in time, interval 0 and t. Next function is is called moment generating function. Moment generating function, and it's called MGF. So MGF is equal to capital E into e to the power x minus mu into t, and it is also equal to E expanded. It will be 1 plus x minus mu into t plus x minus mu whole square t square by 2 factorial plus it will keep on. So this is equal to 1 plus 0 plus mu square into t square by 2 factorial plus mu 3 into t cube by 3 factorial plus dot dot dot. So the mu n, all the mu n, and the nth moment about the mean is the coefficient of Tn by n factorial. So this the coefficient of this is the nth moment about the mean. Nth moment about mean. The next function is distribution is called is based upon propagation of errors. If the error on the measurement, if say we are measuring a function, let's say there is a function f x y dot dot dot, and there is an error on the measurement of f, and this error is say sigma f and that on x is sigma x, that on y is sigma y, so on and so forth. And and sigma x and sigma y are not correlated, not correlated, then we can write sigma f whole square is equal to del f by del x whole square into sigma x square plus del f by del y whole square into sigma y square, and it will keep on for other errors. So what we can see is that if f is equal to x plus minus y, then sigma f is equal to sigma x square plus sigma y square root over sigma x square plus sigma y square. And if f is equal to x by y, then sigma f by f is equal to sigma x square by x square plus sigma y square by y square under root